NENOMATICA, where mathematics meets YouTube excellence. Welcome to this mathematics video where we'll be learning some important identities related to cubes. Specifically, we'll look at the cube of sum, cube of difference, and how to derive some useful results from these identities. Let's begin with our first identity, which gives a formula for the sum of cubes. The sum of cubes, a cubed plus b cubed, equals the cube of their sum, a plus b, all cubed, minus 3 times a times b times the sum of plus b. Let's prove this identity step by step. First, we need to expand the cube of the sum, a plus b, all cubed, using the binomial theorem. This gives us a cubed plus 3a squared b plus 3ab squared plus b cubed. Now let's rearrange this. A plus b, all cubed, equals a cubed plus 3a squared b plus 3ab squared plus b cubed. We can factor out 3ab from the middle terms. A plus b, all cubed, equals a cubed plus b cubed plus 3ab times a plus b. Rearranging this equation, we get a cubed plus b cubed equals a plus b, all cubed, minus 3ab times a plus b. And this proves our first identity. Now, let's look at our second identity, which gives a formula for the difference of cubes. The difference of cubes, a cubed minus b cubed, equals the cube of their difference. A minus b, all cubed, plus 3 times a times b times the difference, a minus b. Let's prove this second identity step by step. First, we expand the cube of the difference, a minus b, all cubed, using the binomial theorem. This gives us a cubed minus 3a squared b plus 3ab squared minus b cubed. Now let's rearrange this. A minus b, all cubed, equals a cubed minus 3a squared b plus 3ab squared minus b cubed. We can factor out negative 3ab from the middle terms. A minus b, all cubed, equals a cubed minus b cubed minus 3ab times a minus b. Rearranging this equation, we get a cubed minus b cubed equals a minus b, all cubed, plus 3ab times a minus b. And this proves our second identity. Now, let's see how we can derive another useful identity using the ones we just proved. This identity states that the sum of the cube of a plus b and the cube of a minus b equals 2 times a cubed plus 6 times a times b squared. Let's prove this third identity step by step. We start by writing the left side of the equation. The sum of a plus b, all cubed, and a minus b, all cubed. We expand each term using the binomial theorem. For a plus b, all cubed, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. For a minus b, all cubed, we get a cubed minus 3a squared b plus 3ab squared minus b cubed. When we add these two expressions, the terms with 3a squared b cancel out, and the terms with b cubed also cancel out. We're left with 2 times a cubed plus 6 times a times b squared. Therefore, a plus b, all cubed, plus a minus b, all cubed, equals 2 times a cubed plus 6 times a times b squared. And this proves our third identity. Finally, let's derive one more identity. This one states that the difference of the cube of a plus b and the cube of a minus b equals 6 times a squared times b plus 2 times b cubed. Let's prove this final identity step by step. We start by writing the left side of the equation. The difference of a plus b, all cubed, and a minus b, all cubed. We expand each term using the binomial theorem. For a plus b, all cubed, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. For a minus b, all cubed, we get a cubed minus 3a squared b plus 3ab squared minus b cubed. When we subtract these two expressions, the terms with a cubed cancel out, and the terms with 3ab squared also cancel out. We're left with 6 times a squared times b plus 2 times b cubed. Therefore, a plus b, all cubed, minus a minus b, all cubed, equals 6 times a squared times b plus 2 times b cubed. And this proves our fourth identity. Let's summarize what we've learned in this video. We've explored 4 important identities related to cubes. First, the sum of cubes identity. A cubed plus b cubed equals a plus b, all cubed, minus 3ab times a plus b. Second, the difference of cubes identity. A cubed minus b cubed equals a minus b, all cubed, plus 3ab times a minus b. Third, the sum of cube of sum and cube of difference. A plus b, all cubed, plus a minus b, all cubed, equals 2a cubed plus 6ab squared. And fourth, the difference of cube of sum and cube of difference. A plus b, all cubed, minus a minus b, all cubed, equals 6a squared b plus 2b cubed. These identities are very useful in algebra and calculus for simplifying expressions and solving problems. Let's start with the problem. We have a system of equations. First equation x is greater than y. Second equation x plus y equals 7. Third equation x times y equals 10. Using these conditions, we need to calculate two expressions, x cubed plus y cubed and x cubed minus y cubed. Let's start by finding x cubed plus y cubed. For this, we'll use the algebraic identity that says the cube of the sum of two numbers equals the sum of their cubes, plus 3 times their product times their sum. In mathematical notation, this is a cubed plus b cubed equals the quantity a plus b cubed, minus 3 times a times b times the quantity a plus b. In our case, we know that x plus y equals 7, and x times y equals 10. Now let's calculate. 7 cubed equals 343. 3 times 10 times 7 equals 210. So x cubed plus y cubed equals 343 minus 210, which gives us 133. Now, let's find x cubed minus y cubed. We'll use another algebraic identity that says the cube of the difference of two numbers equals the difference of their cubes, minus 3 times their product times their difference. In mathematical notation, this is a cubed minus b cubed equals the quantity a minus b cubed, plus 3 times a times b times the quantity a minus b. But first, we need to find the value of x minus y. To do this, we'll use the identity for the square of a difference. The square of a difference equals the sum of squares minus 2 times the product. That is, we can express x minus y squared as equal to x plus y squared minus 4 times x times y. Since we know that x plus y equals 7, we can write that x plus y squared equals 49. Substituting our values, we get x minus y squared equals 49 minus 4 times 10, which gives us x minus y squared equals 49 minus 40, or 9. Taking the square root, we get x minus y equals 3, since x is greater than y. Now that we know x minus y equals 3, we can calculate x cubed minus y cubed. Using our formula x cubed minus y cubed equals the quantity x minus y cubed, plus 3 times x times y times the quantity x minus y. Substituting our values, we get x cubed minus y cubed equals 3 cubed, plus 3 times 10 times 3. That's 27 plus 90, which equals 117. If x squared plus x plus 1 equals 0, we need to find the value of x cubed plus 1 over x cubed. Let's start by setting up our problem. We're given that x squared plus x plus 1 equals 0, and we need to find the value of x cubed plus 1 over x cubed. To solve this problem, we need to find a clever transformation. Here's our approach. We'll first rewrite the quadratic equation to isolate x plus 1 over x. Let's divide the original equation by x. This gives us x plus 1 over x equals 0. Rearranging, we get x plus 1 over x equals negative 1. Now, let's use a known algebraic identity to find x cubed plus 1 over x cubed. There's a useful formula that states x cubed plus 1 over x cubed equals the quantity x plus 1 over x cubed, minus 3 times the quantity x plus 1 over x. This formula will help us because we already know that x plus 1 over x equals negative 1. Let's see how we applied the formula step by step. We know that x plus 1 over x equals negative 1. When we substitute this value into our formula, we get negative 1 cubed minus 3 times negative 1. This simplifies to negative 1 plus 3, which equals 2. Therefore, x cubed plus 1 over x cubed equals 2. Let's begin with our problem. If x plus 1 over x equals a, find the value of x cubed plus 1 over x cubed. To solve this problem, we'll use the algebraic identity for the sum of cubes. The identity states that a cubed plus b cubed equals a plus b cubed minus 3 times a times b times a plus b. Let's start solving our problem. First, I'll write out what we need to find. X cubed plus 1 over x cubed. Step 2, let's use the cubic identity we saw earlier. We'll set it equals x, and b equals 1 over x in our formula. So x cubed plus 1 over x cubed equals open parentheses x plus 1 over x close parentheses cubed minus 3 times 1 over x times open parentheses x plus 1 over x close parentheses. Step 3, Now, let's simplify this expression. We know that x times 1 over x equals 1. So the expression becomes x plus 1 over x cubed minus 3 times 1 times x plus 1 over x. Step 4. Remember that according to our problem, x plus 1 over x equals a. Let's substitute this into our expression. So we get a cubed minus 3 times a. Step 5. Let's simplify our final expression. X cubed plus 1 over x cubed equals a cubed minus 3a. Let's start with our example. If x plus 1 over x equals 3, then what does x to the power of 6 plus 1 over x to the power of 6 equal? Let's start by writing down what we're looking for: x to the power of 6 plus 1 over x to the power of 6. Next, let's rewrite this expression in a different form to see if we can find a pattern. We can rewrite this as the square of x cubed plus 1 over x cubed. Now, we can use the algebraic identity that says a squared plus b squared equals the square of a plus b minus 2ab. Let's apply this identity where it is x cubed and b is 1 over x cubed. Let's simplify the right side of our equation. 2 times x cubed times 1 over x cubed simplifies to 2. Now we need to find what x cubed plus 1 over x cubed equals. We can use another algebraic identity that says a cubed plus b cubed equals the cube of a plus b minus 3 times a times b times the quantity a plus b. We know that x plus 1 over x equals 3. Let's substitute this value in our expression. Now, let's calculate the final result. 3 cubed is 27. 3 times 3 is 9. So we have 27 minus 9, which is 18. Then we square 18 to get 324, and finally subtract 2 to get 322. Therefore, if x plus 1 over x equals 3, then x to the power of 6 plus 1 over x to the power of 6 equals 322. Let's analyze and solve the following problem. Here's our problem. If the quantity x plus y times the quantity x squared minus x y plus y squared equals 1, then we need to find the value of the fraction x to the power of 9 plus y to the power of 9 minus 1 divided by x cubed times y cubed. Let's solve this step by step following the algorithm shown. First, we'll focus on rewriting the numerator of our target expression. We'll express x to the power of 9 plus y to the power of 9 minus 1 in a more useful form. Now, we'll apply an important algebraic identity. We know that a cubed plus b cubed equals the quantity a plus b cubed minus 3 times a times b times the quantity a plus b. This identity will help us simplify our expression. We have our initial condition that x plus y times the quantity x squared minus x y plus y squared equals 1. From this, we can derive that x cubed plus y cubed equals 1. Let me show you how. Now, we can substitute x cubed plus y cubed equals 1 into our expression from step 2. This will significantly simplify our calculation. Finally, we can simplify our expression by canceling out x cubed, y cubed in both the numerator and denominator. Our example asks us to prove that the following equation is true: the quantity 2 plus square root of 3 cubed plus the quantity 2 minus square root of 3 cubed equals 52. To solve this problem, we'll use the formula for the cube of a plus b. Let's recall that the cube of a plus b equals a cubed plus b cubed plus 3 times a times b times the quantity a plus b. Now, let's look at our original expression. We can identify that it equals 2 plus square root of 3, and b equals 2 minus square root of 3. Let's rewrite our original expression using these values. The left side of our equation is a cubed plus b cubed, which equals the quantity 2 plus square root of 3 cubed plus the quantity 2 minus square root of 3 cubed. Now we'll apply our formula for a cubed plus b cubed. According to our formula, this equals the quantity a plus b cubed minus 3 times a times b times the quantity a plus b. Let's simplify what we have inside the brackets. The sum of 2 plus square root of 3 and 2 minus square root of 3 equals 4. This is because the square root of 3 terms cancel out. Next, we need to simplify the product of a and b. The product of 2 plus square root of 3 and 2 minus square root of 3 equals 4 minus 3, which is 1. This is because we're multiplying two binomials that are the difference of squares. Now, let's substitute these simplified values back into our expression. Our expression becomes 4 cubed minus 3 times 1 times 4. Let's calculate the final result. 4 cubed equals 64. 3 times 1 times 4 equals 12. So our final answer is 64 minus 12, which equals 52. In summary, we've proved that the quantity 2 plus square root of 3 cubed plus the quantity 2 minus square root of 3 cubed equals 52. We did this by applying the formula for the cube of a plus b and then simplifying the resulting expressions step by step. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.